Hi, today we are going to talk about purifiers, specifically how to select a gravity disk for a purifier. Every time we bunker a new fuel, the property of the fuel changes and we need to select a gravity disk which should be able to separate, help you separate the water and impurities from the fuel oil. The purification of the fuel ensures an optimum operation, optimal performance of the machineries by supplying them good and clean fuel and lube oil. Now these purifiers work on a centrifugal system, right? This is a purifier or centrifugal machines in which the impure or the unfiltered oil is fed. These machines rotate at a high RPM, high speed, and since the water has a higher density as compared to the fuel, when it is rotated in a centrifugal direction, the water or the heavier liquid comes out and the oil or the lighter liquid remains toward the center. Now, the important part is what gravity disk does is it creates an interface. It creates an interface between the fuel, the clean fuel, and the water and the impurities, so that the water can be taken out from the outside of the purifier and the liquid, the light liquid or the clean oil is taken out from the center of the purifier. In case the gravity disk, the diameter of the gravity disk is smaller, in that case the fuel, the light fuel, the clean fuel will go into the water side, and if it is vice versa, the diameter of the gravity disk is more than the interface where the interface has been built, then the water will come into the clean oil. So how do we decide? Every time we take a new fuel, we decide a new gravity disk, a new size of gravity disk. Now this gravity disk is dependent upon three factors. One is of course the density of the fuel. The density of the fuel plays a very important part, because as per the density, if the density is more, the interface of oil and water will be outside. By that I means further away from the center, and if the density of the liquid, the oil is less, then the interface between oil and water will be more toward the center. Second point is, at what separation temperature are we separating the oil and the water? And third part is the flow rate. So three things we have to keep in mind when we are selecting the gravity disk. First is density of the fuel, separation temperature, and third, the flow rate. The throughput of the machinery, the flow rate of the oil through the purifier. Now, this is the theoretical part. Now let's go and see two different examples on how to select a gravity disk. I'll be using a nomogram. A nomogram is a graph which is given on all purifier manuals. It is used to determine the size of the gravity disk. So let's go. So this is a nomogram which is used to determine the size of gravity disk for a particular fuel. So the model of our purifier is SJ30G/GH, and let's suppose we have a fuel with a specific gravity of 0.98. The separation temperature is 90 degrees centigrade and the feed rate is 1500 liters per hour. So now first is specific gravity. We go and see the specific gravity on the y-axis. We have this 95678, we have this 0.98, and we have this falling graph for this particular specific gravity. And separation temperature is here on x-axis. we have 90 degrees centigrade. So from this point of 90 degrees centigrade, I make an upwards line which is intersecting with this falling graph. You can see here at this point. From this point, I make a straight line to the y-axis and it intersects at this point. Now we see the feed rate, which is 1500, and it is shown on this axis. We have this 1500. We make a line from here to this point. As we can see that this line which we have just made is intersecting with this diameter of gravity disk at this point, between this and this, which tells us that the gravity disk which we'll be using will be 68.5 mm. This is the appropriate size of gravity disk for this fuel, so that we have an ideal interface. One thing I want to mention here is that with the advent of LSFO, sometimes we are getting fuel which is with a specific gravity of 0.88, 0.9, 0.92. In such cases, if we have, let's say, 0.9, and here is the graph, falling graph is here, we do not have any indication for a gravity disk to use if we have this specific gravities. In that case, we have a separate nomogram which is to be used in case the specific gravity is less. I will show you that also. So here we are, another nomogram for the same model but for lower specific gravities. Let's suppose now that we have a fuel with a specific gravity of 0.90. The separating temperature is, let's say, 70 degrees centigrade, and the feed rate is 2000 liters per hour. Now again, 0.90 specific gravity, this is the point, and this is the falling graph. Separation temperature 70 degree, so we go or 70 degree here, and we make a straight line. The point at which this straight line intersects with this graph, which is here, I draw a straight line towards this y-axis, and now this time the feed rate is 2000 liters. So from this point I draw a line to this point, intersection. So now the line which I have drawn is intersecting the area where it is mentioned that the gravity disk to be used is 82 mm. So for this particular fuel and these particular parameters, the gravity disk used will be 82. Please note that for this particular fuel, if I reduce the feed rate to, let's say, 1500, it will be here, and then if I use, it is cutting 86. So it is very, here it is touch and go. It is just cutting 86, and for 2000 it is just into 82. So please make an informed decision. Please, in such cases, please check and make sure that there is no leakage on the purifier. Please, you might have to make a few permutation combinations here, but please keep a close check on the feed rate. Or in that case, I would suggest let's go a little higher, 2200, so that we are more clear of this and we are perfectly in this 82 range. Yeah. So this is how you select a gravity disk for a purifier. Every time you take a new fuel, please go back to the nomogram and select the correct gravity disk. I hope the video makes sense to you. You have learned something new, or maybe revised what you already knew. So if you like the video, please like, subscribe and share. Thank you so much.